Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The question asks which reagents can convert chloromethane, CH3Cl, to methane, CH4, i.e., replace the C-Cl bond with a CH bond, dehalogenation reduction. Step 1 concept. We need a reagent that removes the chlorine from CH3Cl and replaces it with hydrogen, effectively reducing the carbon-halogen bond. Step 2 option A. ZnH+, zinc metal in the presence of a proton source, H+, acts as a reducing agent. Zn reduces alkyl halides, the zinc inserts into the C-Cl bond and the proton source provides H, giving CH4. This is a valid reductive dehalogenation pathway. Step 3 option B. Lyl4, lithium aluminium hydride is a strong hydride delivery reagent. It delivers H to the carbon bearing the halide in an SN2 type fashion, replacing Cl with H, CH3Cl plus Lyl4CH4. This is a well-known reduction of alkyl halides. Step 4 option C. Ng, ether, then H2O, CH3Cl reacts with Ng in dry ether to form the Grignard reagent CH3NgCl upon treatment with a proton source, H2O. The Grignard reagent is protonated, CH3NgCl plus H2OCH4 plus Ng, of Cl. This cleanly gives methane. Step 5 conclusion. All three methods independently accomplish the conversion CH3Cl-CH4. Therefore, option D, all of these is correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.